We're going to be talking about data frames today, so indexing data frames. So what is indexing? It means to select all particular rows and columns of data from a data frame. .lock is location based, .ilock is integer based, and .ix is both integer and location based. So you import pandas as PD and import numpy as NP, so showing two libraries that are used, and then we're making a data frame here. So it's using the PD library to make a data frame with random numbers with a matrix of 4 and 3, and there's an indexing for these letters with these columns. So you see that's like 4 rows by like 3 columns, and then it's checking to see if C is greater than 0 based on numerical method. So X has A, so it's kind of false. Y has B, and I think Z has C. Maybe something like that. But it looks like it's putting it in a Boolean type, which is true and false for each. And it's trying to see where the C is. So I guess if this is indexed as 0, 1, 2, 3, and this is indexed as 0, 1, 2, you're trying to match where the C is. And it looks like it's saying it's in Y. So I guess this one, there's some sort of link between these two. The next example, they're doing something similar where they have a data frame and they have random integers again, and it's 8 by 4. Now they have X, Y, Z, and A, and they're slicing through different values. So they basically put up values for 1, 2, 3, and have 1 by 3 matrix over here. So the 8 values, at least this looks like it's 6, 3, and 3, which makes 6. And then there's 3 separate values here. So I don't really know how it's slicing through each of these based on these integers, but or where it got. I guess these random values are from here. But yeah, maybe we can check the notes to see. Over here, it's making another matrix that's going from 1 to 4 and then slicing. So these are 1 to 4 for each of these and slicing those out. In this one, they have X all the way to Z, and they have 7 values. I don't really know where they're getting their rows and columns from or how it's making it, but let's see if there's something that's more straightforward here. So in this employee data frame, they use PD again. They define various variables on here. So they wrote name as these 4 people, and then they wrote these different departments, and they assigned each value an income and an age, and then they just printed out this data frame. So this one's more straightforward. I guess maybe the slicing might be a bit easier to understand here as well. And they said filter for these items, filter for department, name, and income. So it kind of just excluded the age here while it kept all the other values. They're showing how to transform data frames. So a lot of this is similar to linear algebra and matrix transformations and applications. Pandas transforms helps in creating a data frame with transform values and has the same access length as its own. So you basically import pandas. This is kind of like a dictionary right now where it has these 4 values listed and they each have their own values like 1, 20, 43, none, none. So that'll probably be input somewhere in here. And then there's an index that they added in, which is on it looks like it's a row for each of the different values. And they made a data frame for the index. They had a pandas data frame, and then they printed out the results of the transformation and used the logarithm and exponential function. So we have a value for x, y, z, and a, and it's printing out 2 function values, which is log and exponent. So it probably did like the log of 120 and the exponent of 120 and the log of 40, and then same with 3, and then when I got to none, it's printing as NaN, and then it's printing the value for 34, and then it goes on to the next batch. So that's pretty interesting the way it indexes. And it's now showing us how to add rows. So you use the append function to add in rows. So they're trying to add Romeo in, and they're saying ignore the index. So it's putting all the values for Romeo as NaN. Hierarchical indexing. So this is a technique in which they set more than one column name as the index set. So set index function is used when doing hierarchical indexing. There's a pd.multi-index from the product. So it's putting 2 years and assigning it 2 values for a year and round. The columns, it also has a multi-index from the product. I'm not sure where product is defined, but it looks like this is a function of pandas. and it's saying that these are the people that are there in the product, and that's the subject basically, and this is the class that they're taking, and the data should be rounded up with a random order of 4, 6, and then organized by 1, and then this is doing splicing. So this semicolon just says it's going to an any unlimited amount, and then semicolon semicolon 3. Forgot what this means. I know the negative starts from the left, the positive starts from the right, but this also has some sort of meaning. And then there's a exponent. This one's basically saying plus, like add 19. And we have in the data frame, we have the data, we have the index, and we have the column. So it's printing out a subject, the people's names, the class they take, year round, and then I guess their values for each of the class. Not really sure. Oh, it's getting random values. 4 by 6, 1, 2, 3, 4. Then by 6, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. So these are the 6 values. These are the 4 kind of rows it has, and then it's for 2 different years. Okay, merging data frames. So there's a concat function. It's used to merge the data frames. Employees DB is defined. This is the first kind of function that's defined, and it has the data frame here with name, department, income, and age. And this is the second data frame, which also has the same. And then concat is basically adding them together. So we see that the order is Josh, Mike, Julia, Sergio, and then underneath that we have Burke. So all the rows and columns, they needed to really match up and be a one-to-one relationship, like with the dictionary, and then they were just added on top of, or I guess below, the previous data frame. Okay, joins are really useful. This is important in SQL. So you have an inner join, it returns records that have matching values in both tables. You have a left join, which returns all the rows from the left table that are specified in the left outer join clause, not just the rows in which the columns match. And you have a right join, it returns all records from the right table and the matched records from the left table. You have a full join, which returns all records when there's a match in either left or right table. And you have a cross join, returns all possible combinations of rows from 2 tables. So we have C1 as PD data frame, and it's given the name, and it's giving us age and roll number, and then it gave us marks and roll number. So it probably is doing a join based on the roll number, because those are the records that are in both tables. So initially it's saying do an inner join between these two, and then it looks like it's looking for all the row numbers and kind of lining them up. So 12, 19, 29, 10, 8, and the new ones start here, 190, 29, 48. And then they did a full join. So this one has a concatenation between the 2 different data frames, do an outer join. So I guess wherever it matched up, like 1 or 90 or 29, it basically fulfilled the values and showed what the marks were, but it didn't list out what the person's name was. Maybe these values didn't have names associated with them, but it did put the marks in. You can also do a left join. This one, it looks like it got the person's name in there as well. And then there's a right join. This one, they also got the person's name, but there's also some names that are missing, so you can see how they're different. You can also do a pivot table, and it did it based on income and indexed on department, and then the columns were the names. Pivot tables are probably better to use in Excel, but they can also be used in Python. You can have various aggregate functions that are all these that are already in pandas, and these are mostly statistical methods. And it looks like in this data frame they just defined it and then printed out employees. You got to count elements. The count elements just counts how many there are there. Value counts how much is in each kind of column and row. This counts what's in the rows. And then this one specifically counted for department. This was a general employees count. Then there's mean, median, income sum, min, max. This is standard deviation. This is variance. So that's a lot of statistical methods. Thanks for watching.